tooth is a small, calcified, whitish structure found in the jaws of many vertebrates and used to break down food. Some animals, particularly carnivores, also use teeth for hunting or for defensive purposes. The roots of teeth are covered by gums. Teeth are not made of bone, but rather of multiple tissues of varying density and hardness. The cellular tissues that ultimately become teeth originate from the embryonic germ layer, the ectoderm. The general structure of teeth is similar across the vertebrates, although there is considerable variation in their form and position. The teeth of mammals have deep roots, and this pattern is also found in some fish, and in crocodilians. In most teleost fish, however, the teeth are attached to the outer surface of the bone, while in lizards they are attached to the inner surface of the jaw by one side. In cartilaginous fish, such as sharks, the teeth are attached by tough ligaments to the hoops of cartilage that form the jaw. Teeth are among the most distinctive features of mammal species. Paleontologists use teeth to identify fossil species and determine their relationships. The shape of the animal's teeth are related to its diet. For example, plant matter is hard to digest, so herbivores have many molars for chewing and grinding. Carnivores, on the other hand, need canines to kill prey and to tear meat. Mammals in general are diffeodont, meaning that they develop two sets of teeth. In humans, the first set normally starts to appear at about 6 months of age, although some babies are born with one or more visible teeth, known as neonatal teeth. Normal tooth eruption at about 6 months is known as a teething and can be painful. Kangaroos, elephants and manatees are unusual among mammals because they are polyphyodonts. Some animals develop only one set of teeth while others develop many sets. Sharks, for example, grow a new set of teeth every 2 weeks to replace worn teeth. Rodent incisors grow and wear away continually through gnawing, which helps maintain relatively constant length. The industry of the beaver is due in part to this qualification. Many rodents such as voles and guinea pigs, as well as Leporidae like rabbits, have continuously growing molars in addition to incisors. Teeth are not always attached to the jaw, as they are in mammals. In many reptiles and fish, teeth are attached to the palate or to the floor of the mouth, forming additional rows inside those on the jaws proper. Some teleosts even have teeth in the pharynx. While not true teeth in the usual sense, the denticles of sharks are almost identical in structure, and are likely to have the same evolutionary origin. Indeed, teeth appear to have first evolved in sharks, and are not found in the more primitive jawless fish. While lampreys do have tooth-like structures on the tongue, these are in fact, composed of keratin, not of dentine or enamel, and bear no relationship to true teeth. Though modern teeth-like structures with dentine and enamel have been found in late conodonts, they are now supposed to have evolved independently of later vertebrates' teeth. Living amphibians typically have small teeth, or none at all, since they commonly feed only on soft foods. In reptiles, teeth are generally simple and conical in shape, although there is some variation between species, most notably the venom-injecting fangs of snakes. The pattern of incisors, canines, premolars and molars is found only in mammals, and to varying extents, in their evolutionary ancestors. The numbers of these types of teeth varies greatly between species. Zoologists use a standardized dental formula to describe the precise pattern in any given group. Mammals. Aardvark. In aardvarks, teeth lack enamel and have many pulp tubules, hence the name of the order Tubulidentata. Canines. In dogs, the teeth are less likely than humans to form dental cavities because of the very high pH of dog saliva, which prevents enamel from demineralizing. Cetaceans, like human teeth, whale teeth have polyp-like protrusions located on the root surface of the tooth. These polyps are made of cementum in both species, but in human teeth the protrusions are located on the outside of the root, while in whales the nodule is located on the inside of the pulp chamber. While the roots of human teeth are made of cementum on the outer surface, whales have cementum on the entire surface of the tooth with a very small layer of enamel at the tip. This small enamel layer is only seen in older whales where the cementum has been worn away to show the underlying enamel. The toothed whale is a suborder of the cetaceans characterized by having teeth. The teeth differ considerably among the species. They may be numerous, with some dolphins bearing over 100 teeth in their jaws. On the other hand, the narwhals have a giant unicorn-like tusk, which is a tooth containing millions of sensory pathways and used for sensing during feeding, navigation and mating. It is the most neurologically complex tooth known. Beaked whales are almost toothless, with only bizarre teeth found in males. These teeth may be used for feeding but also for demonstrating aggression and showmanship. Primates. Horse. An adult horse has between 36 and 44 teeth. The enamel and dentin layers of horse teeth are intertwined. All horses have 12 premolars, 12 molars, and 12 incisors. Generally, all male equines also have 4 canine teeth between the molars and incisors. However, few female horses have canines, and those that do usually have only 1 or 2, which many times are only partially erupted. A few horses have 1 to 4 wolf teeth, which are vestigial premolars, with most of those having only 1 or 2. They are equally common in male and female horses and much more likely to be on the upper jaw. If present, these can cause problems as they can interfere with the horse's bit contact. Therefore, wolf teeth are commonly removed. Horse teeth can be used to estimate the animal's age. Between birth and 5 years, age can be closely estimated by observing the eruption pattern on milk teeth and then permanent teeth. By age 5, all permanent teeth have usually erupted. The horse is then said to have a full mouth. After the age of 5, age can only be conjectured by study of the wear patterns on the incisors, shape, the angle at which the incisors meet, and other factors. The wear of teeth may also be affected by diet, natural abnormalities, and cribbing. 2 horses of the same age may have different wear patterns. A horse's incisors, premolars, and molars, once fully developed, continue to erupt as the grinding surface is worn down through chewing. A young adult horse will have teeth which are 4.5-5 inches long, with the majority of the crown remaining below the gumlin in the dental socket. The rest of the tooth will slowly emerge from the jaw, erupting about 1/8 each year, as the horse ages. When the animal reaches old age, the crowns of the teeth are very short and the teeth are often lost altogether. Very old horses, if lacking molars, may need to have their fodder ground up and soaked in water to create a soft mush for them to eat in order to obtain adequate nutrition. Proboscideans. Elephants' tusks are specialized incisors for digging food up and fighting. Some of elephant teeth are similar to those in manatees, and it is notable that elephants are believed to have undergone an aquatic phase in their evolution. Elephants have 4 molars, 1 on each side of the upper and lower jaw. Until age 40, these are replaced by larger molars. The new molars shift forward from the back of the jaw as the old wear down. The final set of molars last for about 20 years. Rabbits and other lagomorphs usually shed their deciduous teeth before their birth, and are usually born with their permanent teeth. The teeth of rabbits complement their diet, which consists of a wide range of vegetation. Since many of the foods are abrasive enough to cause attrition, rabbit teeth grow continuously throughout life. Rabbits have a total of 6 incisors, 3 upper premolars, 3 upper molars, 2 lower premolars, and 2 lower molars on each side. There are no canines. 3 to 4 millimeters of tooth is worn away by incisors every week, whereas the posterior teeth require a month to wear away the same amount. The incisors and cheek teeth of rabbits are called aradicular hydrant teeth. This is sometimes referred to as an allodont dentition. These teeth grow or erupt continuously. The growth or eruption is held in balance by dental abrasion from chewing a diet high in fiber. Rodents' incisors grow continuously throughout their lives, a process known as aradicular. Unlike humans whose amyloblasts die after tooth development, rodents continually produce enamel and must wear down their teeth by gnawing on various materials. These teeth are used for cutting wood, biting through the skin of fruit, or for defense. The teeth have enamel on the outside and exposed dentin on the inside, so they self-sharpen during gnawing. On the other hand, Continually growing molars are found in some rodent species, such as the sibling vole and the guinea pig. There is variation in the dentition of the rodents, but generally, rodents lack canines and premolars, and have a space between their incisors and molars, called the diastema region. Manatees are polyphyodont with mandibular molars developing separately from the jaw and are encased in a bony shell separated by soft tissue. Walrus tusks are canine teeth that grow continuously throughout life. Fish, such as sharks, may go through many teeth in their lifetime. The multiple replacement of teeth is known as polyphyodontia. Reptiles, the teeth of reptiles are replaced constantly during their life. Juvenile crocodilians replace teeth with larger ones at a rate as high as one new tooth per socket every month. Once adult, tooth replacement rates can slow to 2 years and even longer. Overall, crocodilians may use 3,000 teeth from birth to death. New teeth are created within old teeth. Fossilization and taphonomy, because teeth are very resistant, often preserved when bones are not, and reflect the diet of the host organism, they are very valuable to archaeologists and paleontologists. Early fish such as the thelodonts had scales composed of dentine and an enamel-like compound, suggesting that the origin of teeth was scales which were retained in the mouth. Fish as early as the late Cambrian had dentine in their exoskeleton, which may have functioned in defense or for sensing their environment. Dentine can be as hard as the rest of teeth, and is composed of collagen fibers, reinforced with hydroxyapatite. Decalcification removes the enamel from teeth and leaves only the organic interior intact, which comprises dentine and cementine. Enamel is quickly decalcified in acids, perhaps by dissolution by plant acids or via diagenetic solutions, or in the stomachs of vertebrate predators. Enamel can be lost by abrasion or spalling, and is lost before dentine or bone are destroyed by the fossilization process. In such a case, the skeleton of the teeth would consist of the dentine, with a hollow pulp cavity. The organic part of dentine, conversely, is destroyed by alkalis. References. External links. A. Beach, Chandler B., ed. Teeth. The New Student's Reference Work. Chicago, F. E. Compton and Company A.